We've all been there, right? Standing in the aisle, staring at a wall of sunscreens, and you just grab a bottle with a number on it that you trust. But have you ever really stopped to think about what that number actually represents? Well, today, we're going to pull back the curtain on the surprising and frankly fascinating science behind SPF. You see this, and it feels simple. It feels clean. It's like a promise of protection, right? We see SPF 50 and we think, awesome, this will keep me safe from getting torched. We put our trust in it. But is that trust built on a foundation that's as solid as we think it is? Okay, let's really get into this, because the story behind this one little number is way more complex than you'd ever imagine. Seriously, it involves human volunteers, powerful solar simulators, and a global scientific quest to find a better way. So, where do we even begin? Well, before we can start poking holes in the number, we first have to understand what it's supposed to mean. You know, the official definition. Okay, so at its core, SPF is just a ratio. It stands for Sun Protection Factor. And here's what that means in plain English. Let's say it takes about 10 minutes for your unprotected skin to start turning red in the sun. An SPF 50 sunscreen should, theoretically, let you stay out 50 times longer, so 500 minutes before you get that same level of sunburn. It's all about comparing protected skin to unprotected skin. But how in the world do they actually measure that? All right, so that's the theory, but how does it work in practice? Well, this is where the story takes a pretty surprising turn. For decades, the global gold standard for testing SPF has been this one specific method. Get this, the gold standard involves paying people to get sunburned on purpose. I'm not kidding. Scientists take human volunteers, apply a super precise amount of sunscreen to little patches on their back, and then blast them with a powerful UV lamp. Then they wait a day and see where the red patches show up. And the final number? It comes down to a trained expert literally looking at the skin and deciding what counts as perceptible, unambiguous redness. It's surprisingly subjective for a scientific standard, right? So you can probably see where this is going. If your gold standard depends on one person's opinion of another person's sunburn, you're going to have a huge problem with consistency. And for years, scientists in the industry have known this was a big issue. But it took a massive recent study to finally show us just how big of a deal this really is. And this chart, this shows you the problem in black and white. A global group sent the exact same sunscreen samples to multiple expert labs all over the world. We're talking the best of the best. And for a product that's supposed to be SPF 50, the results they got back were all over the place. One lab said 45, another said 58. That's not just a rounding error. That's a huge difference that really makes you question what that number on the bottle truly guarantees. The scientists who ran that study didn't mince words. They said the variability is considerable. Basically, they're saying the system is way more wobbly than any of us, the public, regulators, you and me, would ever expect. So for both scientific and ethical reasons, it was clear that something had to change. Okay, so that's the problem. But this is where the story gets really hopeful and honestly kind of cool. Faced with this big precision problem and a serious ethical dilemma, the global scientific community actually came together to find a solution. The mission was simple, really. They had to move away from the old method of burning people's backs, which, let's be honest, was ethically questionable and scientifically inconsistent. The goal for the new way was to create tests that are ethical, faster, way more precise, and give objective, instrument-based results that any lab in the world could replicate every single time. And this wasn't some small side project. This massive effort was led by something called the ALT-SPF Consortium. It was a huge team-up of dozens of companies, regulators, and top scientists from all over the globe, all working together to basically drag sunscreen testing into the 21st century. After years of work, they landed on 3 main contenders as potential replacements for that old sunburn test. And what's fascinating is that each one tackles the problem in a totally different way. But they're all chasing the same thing, precision and reliability without the burn. First up, we've got the in vitro, or in the lab, method. It's designed to take human error completely out of the equation. A literal robot arm spreads the sunscreen perfectly evenly on a special plate that's designed to mimic skin texture. Then a machine measures exactly how much UV light gets through. It's all about consistency, consistency, consistency. The second contender is straight out of science fiction. In silico, which just means in the computer. This is pure computational power.
Scientists feed a super smart computer model the exact formula, every single ingredient, and the computer simulates how it will all interact with UV light on the skin. It predicts the SPF without ever touching a physical product. And the third method is this really clever hybrid. It still uses real human skin, but, and this is the key part, it's completely non-invasive and safe. A little probe shines a super low level of UV light. We're talking less than 1% of the dose needed for a sunburn, and it just measures the light that bounces back. This real-world data then gets combined with lab data to get a highly accurate SPF. It's the best of both worlds.
So there you have it. 3 brilliant new methods. The consortium put them all through the ringer, testing them on dozens of products in labs all over the world. So what happened? What did they find out? And what does this all mean for that number on your next bottle of sunscreen? Well, the results were amazing. All 3 new methods performed incredibly well. The biggest win was reproducibility. That consistency problem? The lab and computer methods were excellent, even better than the old test. The hybrid method was also really good. And in terms of accuracy, getting the right number, they were all right there. And they got even better with just a few minor tweaks. So what's the bottom line here? The future of SPF testing is all about precision. While the old method gave you a number that was kind of in the right neighborhood, these new methods give you the exact street address. The science is moving from a subjective art to an objective, data-driven process. And this matters to you and me because a more reliable number means we can have more confidence in the product we're buying to protect our skin. This whole story is just a perfect example of science doing what it does best, identifying a problem, collaborating on a global scale, and evolving to create better, safer, and more ethical solutions for everyone. It really makes you think, doesn't it? The number on a sunscreen bottle seems so simple, but behind it is this incredible story of scientific progress. It makes you wonder about all the other numbers and ratings we trust in our daily lives. What hidden science will we uncover next?